Have you ever really stopped to think about what's going on inside a modern robot's head? I mean, what allows it to go from clumsy, fumbling metal to something impossibly graceful? Well, the answer is about to change how you see automation forever. Okay, let's get into it.
So how does that happen? How does a robot make that insane leap from dropping everything in sight to, say, threading a needle? The secret? It isn't better hardware. It's not more lines of code. It's a completely different way of thinking.
I know. That is a huge statement. But look, the old way of painstakingly coding every single movement, every joint angle, for every possible situation, that's over. The new way? It's not about programming, it's about teaching. And that one little shift, well, it changes absolutely everything.
To really wrap our heads around this revolution, we're going to climb what I like to call the pyramid of robotic intelligence. We'll start at the very bottom and work our way up through 4 pillars that, together, turn a simple pile of metal into a truly autonomous learning machine.
So our journey starts with the foundation, the very first pillar, perception. You see, before a robot can do a single thing, it has to be able to see and, this is the important part, it has to understand the world around it. So, what even is perception in this context? Well, think of it as the robot's senses, but totally supercharged by machine learning. It's the magic trick of taking all this raw, chaotic data from cameras and lasers and sensors and turning that mess into a clear, actionable picture of reality.
And here's how it's done. You've got computer vision, which lets a robot tell the difference between a coffee cup and a screwdriver. Then you have SLAM. Sounds complicated, right? It just stands for simultaneous localization and mapping. Basically, it's how a robot walks into a room for the first time and builds a map in its head just like you would. And then sensor fusion brings it all together. The key takeaway is this: the robot doesn't just see pixels anymore. It sees a world it can actually navigate.
Okay, so our robot can see. Now what? Well, let's climb to the second pillar, moving with purpose. This is all about learning how to move through the world safely and efficiently, especially when things are constantly changing. This is basically the robot's brain for movement. And no, we are not talking about a simple pre-programmed path, like a Roomba bumping around. We're talking about real intelligence, the ability to decide the best way to move, from moment to moment, even when the world throws it a curveball.
And the engine that drives this is incredible. It's called reinforcement learning. Think about a toddler learning to walk. It tries something, it falls down, that's a negative reward. It takes a solid step, that's a positive reward. Now imagine doing that millions of times in a simulation. The robot literally teaches itself how to walk, how to balance, even how to run. Then adaptive control acts like a real-time coach, adjusting the plan on the fly for surprises, like a patch of ice on the floor.
All right, we can see and we can move. Now for what might be one of the hardest challenges in all of robotics, actually, physically, interacting with the world. This is our third pillar, the journey from clumsy to truly dexterous. You know, picking things up seems so simple to us, but for a robot, it's a massive challenge. Think about it. How hard should you grip a raw egg versus a heavy hammer? What's the best way to pick up some weirdly shaped tool you've never seen before? The old way of trying to program all that, it was a complete nightmare. The new way, you just let the robot learn. And this right here shows the night and day difference. Forget the old way on the left. Look at the right. This is the big idea. A human, and I mean any human, not just a PhD programmer, can simply guide the robot's arm through a task one time. It's called learning from demonstration. The robot watches, it gets the point, and then it can generalize that skill. So what's the headline here? We've gone from programming to teaching. This basically democratizes robotics. It puts the power to automate things into anyone's hands.
We have made it. We are at the very top of our pyramid, the absolute cutting edge of robotics. This is where perception, movement, and interaction all fuse together to create something totally new, general intelligence.
Just let that sink in for a second. We are no longer talking about a robot that does one specific thing over and over, like welding a car door in a factory. We are talking about a single robot that can perform thousands of different tasks, all from simple, spoken instructions.
So how on earth is that even possible? Through something called robotics foundation models. You know how AI chatbots learn language by reading the whole internet? Well, think of this like that, but for the physical world. These models are trained on massive data sets that connect 3 things: Language, like pick up the red ball. Vision, what a red ball actually looks like. And action, the specific motor commands to go and pick it up.
And now, we get to the payoff. A person can just walk up and say, hey, grab the blue box and put it on the shelf. And the robot, it just understands. It uses its perception to find the box, its motion planning to get there, and its manipulation skills to grab it. This isn't one pre-programmed skill. It's a fluid combination of all the pillars we just climbed, all kicked off by simple language. It just works.
Let me be crystal clear. Everything we just walked through, from the bottom of the pyramid all the way up to this general intelligence, this isn't some far-off science fiction dream. This is happening right now. This is the new architecture of automation.
So, I want to leave you with one final thought. For decades, the biggest problem in robotics was the sheer complexity of programming them. But we've smashed through that barrier. We've turned programming into teaching. So the question is no longer, can a robot do a complex task? The question now is, since anyone can be a teacher, what should we teach them to do first?